Next, we have the mesh topology. Mesh topology is a network configuration where each node is connected to multiple other nodes. This creates a highly interconnected network that is very resistant to failure. There are two types of mesh topologies: full mesh and partial mesh. In a full mesh topology, every node is directly connected to every other node in the network. This setup provides the highest level of redundancy and reliability. In a partial mesh topology, some nodes are connected to multiple other nodes, but some are connected only to those nodes with which they exchange the most data. This is a more cost-effective approach compared to full mesh. Each connection in a mesh network is a point-to-point connection between two devices. Since every node in a mesh network is connected to many other nodes, the network has high redundancy, making it very reliable, as the loss of multiple nodes will often not sever all the available paths between remaining nodes. Additional devices can be easily added without disrupting the existing network, making mesh networks easily scalable on a small scale. One of the disadvantages of this type of network is the large number of connections needed between different devices. If the network is a wired network, then the increased amount of cabling required compared to other topologies increases the cost and labor requirements for setup. The complexity of a full mesh network increases rapidly as the number of nodes increases. The total number of connections can be calculated using the following equation, where C is the number of connections and N is the number of devices. Partial mesh networks are often chosen over full mesh networks in order to gain some of the benefits of redundancy while minimizing the drawbacks of complex management and maintenance when the mesh network is large. Mesh topology is commonly used in wireless networks such as Wi-Fi and Bluetooth networks. It's also found in wide area networks where reliability is crucial, such as in military or emergency services communications. Additionally, mesh networks are increasingly popular in Internet of Things applications due to the robustness and scalability of this topology. Next, we have hybrid topologies. Hybrid topology is a network configuration that combines two or more different types of topologies, such as star, bus, ring, or mesh. This combination is used to optimize performance, reliability, and scalability according to the specific needs and constraints of a network. Hybrid topologies are especially useful in large and complex network environments where a single standard topology cannot meet all the requirements. Hybrid networks can be designed to optimize efficiency for certain operations and data flows, using the most appropriate topology for different segments of the network. One disadvantage of hybrid topology is the complexity of designing, configuring, and maintaining the integration of multiple subtopologies. The cost of deploying and administering a hybrid topology may additionally be greater than a simpler topology. Hybrid topology is widely used in large organizations and enterprises where different departments or segments may have different requirements. For example, a company might use a star topology for individual departments for its simplicity and performance, while connecting these departments using a bus or ring topology. It's also common in large-scale networks like those of universities, where different buildings or areas may have different networking needs and constraints. Next, we have the tree topology. Tree topology is a type of hierarchical hybrid topology that includes characteristics of both star and bus topologies. At the top level, there's a root node, often a hub, router, or switch, connected to one or more secondary levels via a bus. Each secondary level consists of a node that is connected to multiple devices in a star fashion. This arrangement can be visualized as a tree with branches and leaves. This type of topology is well organized and easy to manage and maintain. It is also easy to scale, as new branches can be easily added to the tree. For this reason, among others, this topology is often deployed in large networks, where scalability and clear hierarchy are important. It is particularly effective in networks where multiple departments are interconnected, with each department represented as a star network. Tree topology can also be found in university campuses or institutional networks where different buildings or areas need to be networked in a structured and expandable manner. If you like these videos and you are interested in learning how to set up network security monitoring on your network at home, please see the link in the description below. Every time I post a new video here, I will also post a coupon code for the content provided therein. All sales help me to continue to produce high-quality free content here.